Hello everyone, welcome back, and this is the video in which we are going to discuss the dependency inversion principle. This is the last video of the solid principle series, and this is a very simple principle which says that the high level modules should not be dependent on the low level modules directly. Okay, they should be both the high level modules and the low level modules should be connected to each other via the interfaces. Okay, so that they are not directly or tightly coupled, but they are loosely coupled and the approach is scalable. Okay, now definitions are confusing. Okay, so that is why let me try to explain this with the help of an example, a real life example. Let's say you are building your house. Okay, now you will be needing electricity because you have a lot of electronic gadgets. You have toasters, you have geysers, you have electronic phones, you have televisions, everything. Now suppose that if you create one outlet for each, let's say for toaster you have a different outlet, for geyser you have a different outlet, for laptop you have a different outlet, and that's how you are going to build the electric outlets for you. In that way, if you try to apply a laptop charger in a electric outlet which is supposed to just provide the electricity for toaster, it will not work. Okay, so let us first understand what is high level module, what is low level module here. Your high level module is the outlet which is giving the electricity. Okay, that is the module which is going to power the electronic devices. The electronic devices are your low level module. Okay, so here there is a tight coupling between the high level module and low level module. If you try to put a laptop charger in the toaster outlet, it will not charge it, or it may break. Even the it may your laptop may stop working as well. Similarly, this approach is not scalable. Let's say you bought a new heater. Now you do not have the electric socket for that, so that will require a lot of re-engineering in your electric wiring in your home. So instead of doing all these things hard coded, or instead of having a specific outlet for each electronic devices, which is a very rigid approach, you decided to use the interfaces. You decided to use the common electric socket. The common electric socket is nothing but an interface. Now this interface is so generic that it will work for all types of electronic devices. You want to put a laptop charger, you want to put a phone charger, you want to put a geyser, it will work on everything. So you introduced an interface, and with the help of that interface you removed the tight coupling between the high level module and low level modules. Now your high level module and low level module both are dependent on the interface, they are not directly dependent on each other, and that is the dependency inversion principle. Why it is important? Because in the first approach, where we had the electric outlet for each device, that was a very rigid approach. If you need to scale it up, you will have to do the rewiring. You cannot put any type of charger on any type of socket. You'll have to be very specific about which type of electronic outlet I'm using for which type of device. Okay, and there was a very, that is what the tight coupling was there. So scalability, maintainability, and the coupling was the major issues. And with the introduction of the interface, you are going to get rid of all the problems. Okay, now let's understand it with the help of a Salesforce example. Let's say you have an opportunity service class. This is your high level class. Okay, and then suppose there is an send email class which is going to send an email. Now in the opportunity service class, you have a method which is creating the opportunity, and after creating the opportunity, it is also going to send an email notification to the customer. But you are calling the class which is sending the email directly inside the create opportunity method. So in a way, there is a tight coupling between the high level component, which is the opportunity service, versus the low level component, which is the send email notification class. Okay, this approach is not a very good approach. Okay, because first it breaks the dependency inversion principle. Your high level component is directly dependent on a low level component, which is not a very good approach. Plus here you it is not a scalable approach as well. You can do that, but it is also the violation of single responsibility principle as well, because your opportunity service should not be sending an email. There should be a separate way to do that. Now let's see how, with the help of dependency inversion, we are going to make it a better approach. Let's say in future we introduce the SMS notification. In that case this will not work, this is not scalable. Let's say we introduce the chatter notification, this will not work. I want to have, or we need to write another class for chatter notification and then call that class, and here we'll have to write the logic. If let's say send notification, then send the email notification. If it is chatter, then send the chatter notification, and do the whole lot of code changes on the main class, which is not a very good thing. Okay, so let's see if I try to do it in a better way by using the uh, dependency inversion principle. Okay, so what dependency inversion principle says, that instead of sending the notification directly from the method of opportunity service class, let's create a interface. Okay, now we created an interface which is the notification service, and this has a method which is send notification. It could be anything, it could be chat notification, it could be chatter, it could be push notification, it could be email notification. What it wants is any type of notification. Let's say if it is email, then email notification service needs to implement the interface. Similarly, let's say in future we go for push notification, that push notification needs to just implement the notification service, and notification service interface will make sure that you have to provide the body for the send notification method. Okay, now your opportunity service class will take this notification service as a parameter. Okay, so now this opportunity service class will not be directly calling the email notification service class. Instead, it will just be calling the notification service dot send notification, which is a method written in the email notification service. Okay, so depending on the parameter passed to it, we will be able to identify if we are going to send the email notification or chatter notification or anything. Okay, so with the help of interface, we removed the tight coupling between the email notification and the opportunity service class and introduced an interface. Now your high level module, which is the opportunity service, is dependent on the interface. Similarly, your low level module, which is the email notification service, that is also dependent on the interface. And with this decoupled approach, we will be able to even scale it further. Let's say if in future we want to add the push notification, or we want to add the SMS notification, we need not to change anything. We just need to add another class and implement this interface. So that is what dependency inversion principle is. I have tried to explain it with the help of a very easy example, but it could be very complex when we have the large interface in the picture. So if you go through this and if you face any doubt, feel free to ping me, feel free to send me email, and I'll be more than happy to jump onto a discussion with you to explain if it is not clear to you. With that, I think we'll be completing the solid principles. We have covered all the five solid principles, and I hope this was useful to you. Do let me know your feedbacks as well if you have any, and I'll try to improve on that. Thank you everyone, we'll talk soon. Thank you.